Hey class, what we're going to be working on today is Chapter 2, Section 3, Solving Multi-Step Equations. We only have 3 vocabulary words, so let's turn our attention to those so we can do the following examples. The first vocabulary term is a multi-step equation, and the definition of it is pretty much what you think. Multi-step equations, equations that take more than one step to solve. Our next vocab term is consecutive integers, and I want you to really think about this because the concept of consecutive integers come up in a lot of problems. So you really need to be able to make sure you understand what's being discussed here. So with consecutive integers, you are talking about numbers that come one after one another. So in order of counting numbers. So we can say consecutive integers are integers that are in counting order. Now, the key here, and I'll do this in another color, the key here when we think about consecutive integers is we need to consider what that looks like in terms of variables. So if I told you I had 3 consecutive integers, so something like 1, 2, 3, or 5, 6, 7, if I'm talking about those integers, but I don't know what the first integer is, I can call the first one x, but the next one would have to be x plus 1, right? I wouldn't use a whole new variable to talk about that number because I know that that number, the number after the first one, is just 1 higher. And then the following would be x plus 2, so forth and so on, x plus 3. If I were referring to consecutive, let's say odd integers, and I started off with x, then the next term would not be x plus 1, and nor would it be x plus 3, as some people have suggested. It would be x plus 2. Think about it. If I start off with, if I'm thinking about consecutive odd numbers, I'm thinking about numbers like 17, 19, 21. So notice when I say 17, 19, and 21, I'm skipping. I have to, if I start off with one number, I'm going to have to add 2 to it in order to make sure I skip. The next number, I'm going to add 2 to it again, and I get x plus 4. So when I think about consecutive numbers, I need to think about moving in order, such as counting, but sometimes we'd be asking about consecutive odd or consecutive even, and you've got to keep that in mind when dealing with variables. The next thing we're going to talk about is number theory. The concept or the study of number theory is really just the study of numbers and their relations, and I'm going to jot that down. The study of numbers and their relationships. So that's it for vocabulary. Now we are ready to move on to our examples. Example 1 is about solving multi-step equations, and we have 2 problems that we're going to look at. Remember, multi-step equations just require us to do more steps than one. So as I look at this problem here, I'm recognizing that I want to isolate that variable x. I like to draw a little dotted line here with along my equal sign, just so I know that what I'm doing to one side, I've got to do to the other. So as I look at this, I sometimes liken a problem like this to trying to get at something. I'm trying to get at x, and so the 2 things that are bothering x are 11 and negative 4. Since this 11 is attached to x by multiplication, I'm going to save that for last and get rid of the 4 first. In order to get rid of this 4, I'm going to add its opposite. So I'm going to add a positive 4 to both sides. I'm undoing this negative 4 by adding a positive 4. When I do that, I have 11x is equal to 33. Now I can attack this 11 and get rid of it. 11 is attached to x by multiplication, so I'll do the opposite and I'll divide. Again, what I do to one side, I've got to do to the other. When I divide both sides, I'm left with x is equal to 3, and I'm done. This next problem is a little bit more involved. Not that it's harder, but the concept, you have to really kind of think about what's going on. We remember that the division sign is a type of grouping. So in a sense, there is a parenthesis there, which says 7 is attached to A. And I need to first deal with the 8 before before I can get at the 7 that's attached to A. So I'm going to do that. How is 8 troubling this A plus 7? Well, it's being divided by. So in order to undo division, I'm going to multiply. So I'm going to get rid of this B. What I do to one side, I'm going to multiply by 8. I have to do to the other. So these guys cancel out. I'm left with A plus 7 is equal to 5 times 8 gives me 40. Next, this looks like one of those easy solve it problems. So I'm going to do the opposite. This 7 is being added. I'm going to subtract. I subtract 7 from both sides. I'm left with A is equal to, there's my line again, A is equal to a positive 33. Okay, so here's example 2. Example 2 requires us to kind of use our skills that we've talked about, but we're going to first do it in a real world example where we've got this word problem. After finding a pair of skis on sale at 2/3 the original price, Hiroshi used a $25 coupon and paid $115 for those skis. What was the original price? So as we look at the problem, we need to kind of consider what it is we're looking for. We're looking for the original price, so let's call that X. And we know that what he ended up paying was 2/3 the original price. So I'm going to start off by writing 2/3 X. So that is the sale price. That is the sale price that he ended up paying, but he had a bit of a coupon which took another $25 off. So if I subtract 25, that should equal the price he ended up paying, which was $115. So there's our equation. And yes, it is a multi-step equation, but we can handle that. So what we're going to do is, we see that we've got our X term here. We're going to leave that alone, and we're going to add 25 to both sides in order to isolate the X term. Then we'll get X by itself. So I add 25 to both sides. When I do that, I have 2/3 X, and that's equal to 140. And now I need to just solve for X. When I'm multiplying X by a fraction, in order to undo that, I'm going to multiply by the reciprocal. So I multiply by 3/2, and what that does is that takes care of that coefficient and makes it 1, so I'm dealing with 1x. What I do to one side, I've got to do to the other, so I'm going to multiply that side by 3/2. When I do that, lots of nice canceling happens. I'm left with X is equal to, 2 goes into cross-canceling, 2 goes into 140 70 times. It goes into itself 1 time. 70 times 3 gives me 210. I find out that the original price of the skis was $210. All right, here's our final example, example 3. And here we're going to use the concept of consecutive numbers. We're going to find 3 consecutive odd numbers with a sum of -51. So we realize that we're dealing with consecutive numbers. If the first number is X, what's the next number going to be? Well, first number is X. The next number has to be X plus 2. Because if this number is odd and we want consecutive odd numbers, we're going to have to jump up 2 spaces. So X plus 2, and the next number will be 2 away from there, which will be X plus 4. So here are the 3 numbers that we're going to look at that's going to add up to, they're odd, they're going to add up to -51. So let's do it. X plus 2 plus X plus 4 is equal to -51. What I'll do at this point is just join like terms together. I'm going to simplify one side of my equation. When I do that, I've got 3x terms, so that's 3x. And then I have 2 and 4, which is going to give me 6. And that's all equal to -51. Next thing I'm going to do is subtract 6 from both sides, or add a -6 as it were. And I have 3x is equal to -57. With that in mind, my final step is to divide both sides by 3. And I shouldn't call it my final step. Well, the last step of solving this equation is to divide both sides by 3, and I get a -19. With this -19, I have to actually solve the equation, solve the problem that is, by plugging in -19 in for x for each of these to get all the 3 consecutive numbers. So -19 plus 2 is -17. -19 plus 4 is -15. And so here are the answers to my problem.